Why, hello there. Let's go ahead and talk about Lesson 5-4 assignment, congruent triangle proofs together. Number 1, given that segment MS is congruent to segment RQ and segment MS is congruent to segment RQ, prove that the triangle MSP is congruent to triangle RQP. So let me go ahead and begin by marking the picture. I'm going to go ahead and look at this particular these two segments here. Segment MS is congruent to segment RQ. Okay, I can see this is segment MS and this is segment RQ, and they are congruent. I know it's already marked for us, but I'm going to go ahead and mark it again. So there's those tick marks to indicate that those are congruent. And notice that it says that segment MS is parallel to segment RQ. So again, this is MS and this is RQ, and they're parallel to each other. It's already marked for us, but we're going to go ahead and mark those arrows again. So we're trying to prove that triangle MSP is congruent to triangle RQP, right? So since I know that these two things are congruent and they are parallel to each other, because we have these arrows to indicate they're parallel, what I'm going to go ahead and do is I'm going to extend the lines, because when I have parallel lines, of course, they're going to be cut by a transversal, okay? So that means that this angle here is congruent to this angle here, okay, by the alternate interior angles. You can see that these angles are alternate and they are inside the parallel lines, okay? Okay, so what else? Let's just, for the heck of it, I'm going to go ahead and put these two angles here because those are congruent by alternate interior angles as well. Okay, so I'm pretty much done with this, and I'm pretty much done with this. So now I'm going to go ahead and do the second part, which is look at the picture. What do I notice? Okay, so I can see that these angles here are congruent by vertical angles. Specifically, we say that this is angle MPS, which is congruent to RPQ, angle RPQ. So P needs to be in the middle when you're writing those two angles because that's the vertex, okay? So these are what we call vertical angles. These angles are congruent to each other. Okay, so let me go ahead and start the proof, because the first thing that you have to write is your given, which is segment MS, which is congruent to segment RQ, and MS is parallel to RQ, and that's because of given. That's your reason. Then number 2, note that by alternate interior angles, I'm gonna use a different color, angle SMP is congruent to angle QRP. And that's because of alternate interior angles. Okay? And then here, we are forced to work with the vertical angles theorem. And we did say that angle MPS is congruent to angle RPQ. And that's because of the vertical angles. Okay? So then, for my fourth statement, I gotta use the proof. So triangle MSP is congruent to triangle RQP. And why are these two triangles congruent? And I have to use the reasons that I was working with, right? So to prove that these two triangles are congruent, yes, it does look like we're dealing with angle, side, angle, right? And these parts do correspond. I could say angle, side, angle, but we cannot neglect the fact that we are forced to work with the vertical angles, right? So there were two ways to prove that these two triangles are congruent, right? Angle, side, angle. You can see that with my laser pointer here. But we didn't include the vertical angles when I was using my laser pointer right there just a few seconds ago. We have to work with the vertical angles theorem. So, I just realized I need to put like 2 arcs there. So, actually 3 arcs, because there's 2 here. So what do I have to do? I have to include the vertical angles because that's part of my reason. So let me go ahead and say, okay, so this angle here corresponds with this angle. And this angle here corresponds with that angle. And this side corresponds with that side. So what do I have? Well, let me put this A over here. Well, I have angle, angle, side. And then since I started here, I got to start with the 3 arcs here. And then follow that same pattern. Angle, 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 side, right? So these two triangles are congruent by angle, angle, side, where we have to use the vertical angles theorem to prove that the two triangles are congruent. Okay? So just keep in mind, there are 2 ways to prove that the two triangles are congruent, but since the problem deals with the vertical angles theorem, we have to use that into consideration as we prove that the two triangles are congruent, okay? Hopefully that makes a lot of sense on what you're trying to do for this problem. And thank you for those who did realize that these two triangles are congruent by ASA, but again, for the like 100th time already, we have to use the vertical angles theorem in order to prove that the two triangles are congruent, okay? All right, so let's go ahead and take a look at number 2. I'm not going to go over the whole thing, but I can do number 1, the statement and the reason, by the way. I can do this. This is easy. Segment BC bisects angle ABD and angle ACD. Number 1 reason would be given, okay? And then by the definition of angle bisector, you know that segment CB bisects angle ABD. So this is your angle bisector. It bisects angle ABD. Oh, and it also bisects angle ACD. So it splits those angles into 2 congruent parts. So then you should definitely look at your picture and put that in your proof, and then perhaps you will use that reflexive property right here. Okay, so hopefully that will help you get started with that proof. So whatever you mark here, you should write it here, if that makes sense. Okay, so let's take a look at this. Number 3, angle PQR is congruent to angle SRQ, and angle 1 is congruent to angle 2. Okay, all right. So angle PQR is here, and it's congruent to angle SRQ. And then note that angle 1 is congruent to angle 2. Okay. So I'm dealing with these 2 triangles. Here is triangle PQR and triangle SRQ. Note that these 2 triangles do share the same side here. So I can go ahead and input a tick mark there. I'm going to put a tick mark right there. Okay? And, well, are these two triangles congruent? Okay, so let me go ahead and take a look. So I'm going to draw triangle PQR and triangle SRQ. And we know that this has an arc there, and R has an arc there, and then they both have a tick mark. They both have a tick mark here and here. And then what else do I need to say? And then we can see that this thing has those double arcs there. So I'm going to go ahead and put 2. Actually, nope. Wrong one. 2 here. And then this has an arc here. So I'm going to go ahead and put 2 there. So I can see that these two triangles are congruent. Well, this angle corresponds with this angle, and this segment corresponds with that segment, and this angle corresponds with that angle. So that means that these two triangles are congruent by ASA. Okay, so let me go ahead and start the proof with y'all. So this is copied from your given, so I will say that the reason is given. And segment QR is congruent to segment QR. That's the reflexive property. And triangle PQR is congruent to triangle SRQ. Y'all, look at this. If you're proving the two triangles congruent, you're using the you're going to use the 4 shortcut theorems. I'm sorry, you're going to use one of the 4 shortcut theorems. And that means ASA, SSS, SAS, and AAS. Hopefully I have everything there. I can't remember what I just said. But we said that these two triangles are congruent by angle, side, angle, right? So now, what's number 4? Well, I'm proving that segment PR is congruent to segment SQ. I'm not proving that the two triangles are congruent. Well, I already did over here, but the last thing, if it says that you're proving something else, not the two triangles congruent, then you're going to use something called corresponding parts of congruent triangles are congruent, aka CPCTC. Okay, so it's CPCTC for that one. All right, so let's go ahead and let you try all this as an exercise. Okay, so I wish you luck on the homework assignment. If you have any questions, you know what to do. Toodles.